think I thought before, this one, okay, will be quite important. This type of question is very important in your exam. Okay, first they will ask you to show something, become a anyone.
Sir, are you recording?
Thanks for reminding. Okay, so I continue. Okay, so the second part, sin z equal to 0. This one, use what you have proved, okay, and make it equal to 0. But when we set equal to 0, both the imaginary and the real part will be equal to 0. So you will have two equations. One part is this one equal to 0. One part is this one equal to 0. Okay, so we solve two, and then we have two parts. How I know I should start with which one? Okay, then what we do here, okay, you just, okay, let's say I take the first one, okay, sine x cos hyperbolic y equal to 0. Okay, so what happened here? Cos hyperbolic y won't be equal to 0. Okay, cos hyperbolic y cannot be 0. So what you can do is you must you only can have your sine x equal to 0. So sine x equal to 0, that means your x will be n pi. Okay, because as we know, the formula of cos, why we said cos cannot be 0, huh? Okay, because according to the formula or definition, what is the cos hyperbolic x? Will be e x plus e negative x dot I, is it? I is I divided by 2. Let me check. I can't remember the formula. Cos hyperbolic x. Sorry, I can't remember the formula, but the formula is inside the notes lah. Okay. So cos hyperbolic ix will be, okay, so cos hyperbolic x will be ex plus e negative x. Yeah, no I there. Okay, so it will be this formula. But this formula ex, no matter what number you put for your x, you still will get a positive number. This one is a positive number. And then this one also the same. Okay, if you put your x normal number lah, any number, then you will get a positive number. Unless you put until your x is a very, very big number, let's say e power of negative 99999, then you will get something very near to 0 or equal to 0. But the less number is 0. So it will be greater or equal to 0. Okay, logically must be greater than 0 lah, cannot be equal lah. Okay, so something positive plus something near to 0 or greater than 0, and then divide by 2. Of course, this one you won't get 0. Okay, so that's why we're trying to look for starting with this, starting with 1, not starting with 2. Because starting with 2, this one can be 0. This one can be 0. So I have no idea where to start. So try to find something with cos hyperbolic. Because cos hyperbolic cannot be 0. Sine hyperbolic can. Sine hyperbolic, the formula is if not mistaken lah, ex minus the e negative x divided by 2. Okay, if your x is 0, 0 here, then you will get 1 minus 1 divided by 2. That means your sine hyperbolic y can be equal to 0, or your sine hyperbolic x can be equal to 0. So that's why I don't start here. I start with the first one. Okay, I start with the first one, and then because this part cannot be 0, that means only this part can be 0. This part can be 0, then x will be n pi. Sometimes it's cos, sometimes it's sine. No, not necessarily must be sine. Okay, so I get the x. Okay, after I get the x, I put inside here. Then I can get what is my y, because cos n pi will be negative 1 power of n, and then sine hyperbolic y equal to 0. Hence, I know that y is 0. Okay, if I start from 2, then if cos x is 0, that means my x is no more n pi. X will be 2n pi divided, something like n pi plus 1 divided by 2, something like that. Okay, then will be, everything will be different. Okay, so I don't start with 2, because if you start with 2, you have 2 possibility. So we start with 1, which is only can give you one of that is 0. Okay, so that's why I know that the answer is equal to n pi. Sorry. Okay, so I continue. Okay, so now this is a complex rhythm. Okay, so let's say that means now what we do is we have log, but not the normal log. Normal log like log 3, log 5, log 10, and then given the best, let's say 5 or E, something like it. But E normally we set long 3. Okay, if we set log 3 without anything, that means it's 10 and so on. Okay, but here, this one will change. No more only real number, but will be the complex number. Okay, and then we write as log z or we write as log z. Okay, so where W is equal to log z and then Z is EW. That means it's the same thing lah. Just like I have log 3 power of 5 equal to x, let's say lah. That means will be 3 is the best number, so best number here. And then this is a power, and then equal to 5. It's the same thing. Now you have log z equal to W. Is it? Am I correct? Or log W equal to Z? Okay, log Z equal to W. So that means, sorry, based on E, because it's exponential, okay, and then Z equal to W. So it will be the same thing. E still the base number, and then power is W equal to Z. So that's why we have this one. Z is EW. Okay, so here you have to know that EW won't equal to 0. Okay, EW won't equal to 0, that means you won't have log 0. Okay, you won't have log 0. So that's why log 0 is undefined, no matter what is your Z. This one is also the same for the real number lah. Okay, and then next one. What's that? Okay, so next one. If let's say we set W is equal to U plus IV, okay, let's say this is my W lah, and then that is REI theta, which this one is a modular form, okay, then we can set, okay, this one, because W is log Z, okay, W is log Z, or we can set Z is EW, okay, Z is EW, so okay, that means this part, E of your W, okay, E of your W, because your W is U plus IV, and then your Z is EW. So that means E of U plus IV, you can refer to REI theta, okay? REI theta, where this part, okay, EU plus EIV. Okay, if you compare with RE, okay, REI theta. So what you see here, okay, this is a real number, and then this is an imaginary number. Okay, so same thing here. This one I also can separate to EU times with EIV equal to REI theta. So what you see here, EU is real number. So that means your R will be EU. And then your EI theta will be, EIV will be EI theta. In other words, your V will be your theta. Okay, so that's why V is equal to theta, EU is R. That means your U will be log R lah. V is still the same. Okay, in other words, if you want to find the log Z, okay, because your W is log Z, so that means your log Z is this one. Okay, your log Z is U plus IV. And then your U is what? Your U is log R. So that's why I substitute with log R. And then plus IV, what is your V? Theta. So that's why log Z is also this one. Okay. So this is how we get into this equation lah. Okay. So I continue. So here you have to take note, because your log Z is ln z is equal to ln of the modulus of z, this one still okay, only one number, but argument is something, okay, when I said argument, let's say I said 3 plus 4i, be here, something here, okay, so 3 plus 4i, so this is 3, this is a 4, I just agak-agak lah, huh? This is a 4, so this is your z. So when you want to find the argument, so the theta will be tangent inverse of 4 over 3. I don't know what is that. Sorry, I get my calculator. Let me use my calculator. Oh, okay. Okay, so we try to calculate shift tangent 4 over 3. So I get 0. I don't know whether it is 9273, let's say. Okay, this one is radian. Okay, so this value, this one is not the only answer for my theta. It can be something like this one after turn one round. So that means it can be actually is 0.9273 plus 2 pi, 2n pi, sorry, 2n pi. If turn one round, that means your n is 1. If turn two round, that means your n is 2. Without turn, that means your n is 0. So that means you have infinitely answer here for your theta. Okay, if you try when n equal to 1, that means 0.9273 plus 2 pi. Okay, if you try to get the tangent of this one, okay, get the tangent of this one, you will get back the 4 over 3. That means you will get back the same position here. Okay, so that means it will be, it depends on you turn how many times. So your argument will be something infinitely, okay, infinite answer. So that's why they said infinite many value. Why? Because the argument of z here. Argument of z, you have infinite answer. So that means whole thing there you will have infinite answer. Okay, this is what they mean lah. Okay, so we continue the definition, the next definition. So if you have a ln z, then we can write also ln z actually is ln z plus argument of I times argument of z. Okay, so and then ln for complex number also the same. When you have z1, z2, that means it's z1 plus z2. Okay, and then if divide, that means would be minus. It's the same as a rule of logarithm. Okay, so try to understand the example, this example first before I continue. Try to have a look. Just a simple one. Okay, so now let's see. They said I want to find this one. Ln of 3 minus 4i and its principal value. So that means I want to find this one. So according to the formula, it's formula of this one. So that means I want to find a ln of this one. That means I need to find modulus of 3 minus 4i first. Modulus of 3 minus 4i will be square root of 3 square plus 4 square, which is 5. Okay, I direct give the 5. And then argument. Argument of 3 minus 4i. So now we try to draw. Where is 3 minus 4i? So 3 minus 4i will be something here. Because this one is 3, this one is negative 4. Okay, so now you want to find this one. So how are you going to find? You just tangent inverse of 4 minus 3. But 4 minus 3 will be something positive. So when you want negative, then you put a negative here. Okay, so now let's see what is the answer. Shift tangent of 4 minus 3, 4 divided by 3. So I get the answer as 0.9273. So this one will be my argument, which is what? 0.9273. Okay, so that means what is my answer for this one? Okay, according to the formula here, so ln of 3 minus 4i will be equal to ln of the modulus, which is 5. Okay, so plus of negative of this one, so become minus. So minus of I times 0.9273. Okay, so this is called principal value. Okay, why we call principal value? Principal value, that means just now I said already. Okay, this one is when you have negative. This one is when you have no turning. Okay, you have no turning. If you turn one round, that means you have to plus 2 pi. If you turn 2 round, that means you have to plus 4 pi. Turn 3 round, plus 6 pi, and so on. I got phone call. Sorry, Okay, sorry, we continue. Where I stop, where I stop. Okay, so this one, that's why we have the plus 2k pi. When they ask a value, okay, when they ask a value, you have to put ln 5 plus, okay, I of this one, you want to put like this one negative tangent inverse of this one also can. You want to put the negative 0.9273 also can, but don't forget to put the 2k plus the 2k plus. If they ask a principal value, then you just take this one as 0. So this one will be your principal value. First answer will be when your k is equal to 0. Okay, so I continue first. Okay, we want to solve for z each of the following equations. So I have this one. Let's say I solve this one first. So that means that I want to get the z. So how to get the z? I just ln both sides. Ln both sides, that means I will have ln sub 3 plus I. So that means this one. I need to find what is and then square root it will be 2. And then this one will be tangent inverse of 1 divided by square root 3, which is pi over 6. Okay, this one should be okay. And then this one, I want to get the z. Okay, I want to get the z of this one. So how to get the z of this one? So what should I do is I exponential both sides. So exponential both sides, e ln z, I will get z. And then e2 plus pi over 4 I. So that means here, because I have two parts, one part is real number, one part is imaginary number. So I will have e2 and then times with e pi over 4 I. So e2 will be my real number, okay? Will be one real number, and then e pi over 4i, that means it's cos pi over 4 plus I sine pi over 4. Hence, I get the answer of this one, and then simplify it. Cos pi over 4 is 1, and then sine pi over 4 is also 1, so I will have this one. Okay? Sorry, 1 over square root 2, not 1. Okay, and then next one. Next example. Cos hyperbolic z equal to negative 5i. So what is your cos hyperbolic z? Cos hyperbolic, you have to take note lah. Okay, similar to the example just now. Okay, which I said this one. Okay, so we have a look. So if you expand the cos hyperbolic, you will have cos hyperbolic x cos y, sine hyperbolic x sine y. Okay, and then negative 5i, that means it's anything not 0. Okay, we start with this one because this one equal to 0. Okay, so that means cos hyperbolic x cos y equal to 0. Again, cos hyperbolic won't give you 0. Only the cos x cos y will give you the 0. Okay, cos y equal to 0, that means it's n pi plus pi over 2. Okay, you can try y equal to 3 pi over 2, 5 pi over 2, 7 pi over 2, or pi over 2, you will always get 0. Okay, you will always get 0. When you cos this whole number, you will always get 0. So since you have this one, okay, and then now you put in here. Put in your sine n pi plus pi over 2, 1 power of n equal to negative 5, because you have negative 5 divided by negative 1 power of n. So that means this one, it will be 5. And then, because negative, okay, it can be, negative 1 power of n. Because if you have this one, that means it's negative 1, okay, divided by negative 1 power of n. So it will equal to 5 times, okay, it can be something like this, negative 1 and then 1 minus n, okay, 5 times negative 1 power of 1 minus n. Like this one also can, or like this one also can. Because it should be the same. Okay, it should be the same. When your n is 1, then you will get 0. Okay, get 0, that means you will get a 1, positive 1. So same here. If your n is 1, 1 plus 1 is 2. Negative 1 power of 2 is still 0. It's still 1, sorry, positive 1. So that's why they change to n plus 1. Okay, so n plus 1. So that means your x will be what? Your x, you move this whole thing here. Because it's sine hyperbolic, that means you can move out. Cos hyperbolic, you cannot. Okay, because sine hyperbolic negative 5 is equal to negative of sine hyperbolic 5. Okay, inverse also will be the same thing. Hence, I have my x is this one. Okay, I suddenly have here. Oh, okay. This is sine hyperbolic. Okay, sine hyperbolic. If you want to change to ln sine hyperbolic, let me have a look. How come they suddenly change here? This one just simple lah. This is because here is x and then plus your I of argument. Okay, that means plus your I of y. And then what is your y is n pi plus pi over 2, which is this one. But here I have to look, y suddenly square root 26. Sine hyperbolic inverse of 5. This one's still okay, but suddenly jump to here. How come suddenly become ln? Sine inverse of 5. Let me see. 2.312. 3.231. This one in your calculator, they can give you the answer. You no need to, not necessary to change it into this form. You can make it into a 2.312. You just direct put here 2.312. Okay, I think there are involved some rule here, but I does not show the rule. So I don't see why they can get this one lah. But never mind. Okay, you just give your answer in the 2.312 is also okay. Okay. So before I proceed, we have a look for the tutorial. Okay, I think I asked you to do the sum questions there, is it? Have you did it or no yet start? Now you should able to done all the question in the tutorial 1 already. Let me see, tutorial 2 can or not? Tutorial 2 not yet because it's something differentiation. So you can proceed with tutorial 1 first. Have you start to do? Okay, you try to do you take a rest. Okay, maybe we'll rest a while. And if you don't want to rest, never mind. You try to do the question 1, question 2. Later we discuss on it. Okay, question 3 as well. Later we discuss on these 3 questions. 5 minutes, huh? Okay, so we have a look for the questions one. Okay, so now we have a look. I want to find the image of the following under the transformation of f z equal to 1 over z. So f z is equal to 1 over z. Okay, so where the 1 1 that means okay 1 over z, so that means it will be x equal to 1, y equal to 2. So that means this is 1 over 1 plus 2i. Okay, 1 plus 2i again will be, don't let the I on the denominator. What we do is we will rationalize it. That means I times a 1 minus 2i. Whatever you times here, whatever you times out there. Oh, sorry. So that means it will be 1 minus 2i divided by 1 plus 1 times 1, 1. Okay, 2i times negative 2i will be 4. So 1 plus 4. So that means you 2 over 5i. Minus I times 2 over 5. So in other words, your x will be 1 over 5. The y will be negative 2 over 5. So it will be 1 point in the z plane. Okay, this one is an image. This one is an image on the z plane. Okay, and then 2. Y equal to mx. Y equal to mx, that means, okay, again this kind of questions will you have two way. If you still remember lah. Okay, one is your direct substitute. Let me see. Okay, one is your direct substitute. One is you try to compare. Okay, if let's say you okay, let's see if you direct substitute, that means your z will be something x plus imx. Okay, there are sometimes one method is only work for one questions. Okay, we try to have a look. So now that means what would be your fz? We try to find what is our fz. Will be 1 over x plus imx. This one you want to continue also can. Okay, then what will be there will be you have to times x minus imx and then x minus imx. But it will be quite long in order to proceed. Okay, in order to proceed, it will be something like this: x minus imx, and then you have 2x squared, x squared plus m squared. And then you have to separate them, and then you have to find out what is the relationship between the u and v. So that means x divided by x squared plus m squared x, and then minus by x squared plus m squared x. So what you see here, what is the relationship of this one and this one? They are the same. They are the same. That means you are having something like, okay, let's say you have u plus iv lah, u plus iv. U plus iv, that means this one will be u, okay, minus, because this one should be your negative mu should be v. you compare with U plus IV. U plus IV, that means okay, what is happening there? The V is negative MU. So that's why I have negative MU here. That means that when you draw, you'll be having something like this. Because your M is something constant. Your M is something constant. Okay, so this one you will have straight line like this. Okay, you are having a straight line like this because what you have is this one is U, this one is V. Okay, so of course, if you don't want to do this way, you have another way. Just like just now what I said. Okay, so now I know the Y is mx. Okay, I know the Y is mx, and then my fz will be 1 over x plus imx. And then what you have here, I know that this one actually is x minus, just like here, okay, where I have this one. Of course, both ways is the same for these questions, okay? And then you compare, because this one is equal to W. What is W? W is U plus IV. So what you do is you compare the U to this one, and then the V to this one. Then you will get the same answer. Okay, this is just the idea. Okay, now let's see. The third one. Y equal to mx plus c. Okay, so since now it is y equal to mx plus c, so that means now your fz will be something 1 over x plus I times mx plus c. Okay, so you try to continue first. See what you get here. Okay, so I think if you continue this way, you will find something very difficult to continue with it. But still, it's possible lah. You times this one, and then times this one. Still possible to proceed, but it will become very complicated, and it's maybe you cannot get this equation. You can get some equation, but not this equation. Okay, you will get something like, okay, you will get x minus I, and then mx plus c, and then divide by, okay, this one you will get x squared plus mx plus c squared. Okay, so what you have here, you will get, okay, this one is your v. Your v is x divided by x squared plus mx plus c. Okay, and then what is your v? Your v will be something, okay, negative of mx plus c. Plus, then become the same. Do first, you have to move your negative to there, okay, and then you will get mx plus c divided by, okay, this whole thing. I don't, I'm so lazy to copy or copy again. Okay, and then what is next? You need to move your c and move your x there, m there, sorry. So that means this one you will have negative v over c minus divide, sorry, negative only you will get, okay, x minus c, yeah, x squared, and hence I know this one actually is my u plus iv. This is u. Okay, so this one will be equal to my u. Hence, okay, what is the relationship there? You will get something. Of course, you won't get something like this. Okay, but what you get will be negative v. Am I correct? Am I miss out anything? Oh, okay. Everything wrong. Sorry. This one you cannot simply move your negative c like that. Okay, you have to move something like, okay, this one you move there, you move here, so you will have something like negative v, and then minus c over this whole thing, and then only equal to mx divided by this whole thing. So that means it will be very complicated if you don't want the x, because what we want to do is we want to remove the x. So it will be very complicated for you to continue for this one. So here, okay, we don't use this method. Okay, instead of this method, we use another method. What is the method? Okay, I know that my w is 1 over z. It is x plus iy. We know that. Okay, what is your w? W is u plus iv. Okay, and then your u plus iv, that means this one will be u minus iv. Now I times the u minus iv, u minus iv. And then now I can compare. What is my x? X is u over u squared plus v squared. Okay, and then what is my y? Y will be negative v divided by u squared plus v squared. Okay, and then if I don't want the x and y, I want to make the mx, the x and the y gone. Okay, I know that this is mx plus c. Okay, and then continue. Substitute your x inside and then see what happens. This one, the one. You continue. Try to see. Okay, so we continue. Okay, you can make your m times, sorry, 1 minute. Okay, so if you continue, you will have mx v divided by u square plus v square. And then what you do is you whole thing times your u square plus v square. Then you will get something like this. Okay. only the last step. You just need to times everything and then move to in front. Then you have this one. Okay, so any questions before I proceed to the question 2? Okay, if you have no questions, I proceed again. Okay, I do the question 2-1 and then I left the question 2-2 to you. You try to do. If not okay, then only I will do it next week. I mean, sorry, tomorrow or next week. Okay. So I want to compute the EZ, okay, in the form of U plus IV. So, and I also want to find this one for each of the following. Okay, so that means Z is 3 plus pi I. Z is 3 plus pi I. That means if you want to find the E pi I, okay, and what is E pi I? E pi I will be cos pi plus I sin pi. Cos pi will give you cos pi. Cos is something like this, okay? So we give you negative. So that means you will have E3, -1. Sin pi will give you 0, so plus 0. So that means your answer will be negative E3. And if you want to find the modulus of EZ, that means will be E3. That means will be modulus of negative E3. That means your answer will be E3. Okay. And then I will left the 2-2 to you. 2-2 will be almost the same as 2-1, so I don't want to do. Okay. So is it okay if I proceed again? Okay, so I proceed again. Question 3. Again, question 3, I also just do one part. The rest I left it to you. I want to find the real and imaginary part of E negative Z square. So what is E negative Z square? E negative Z square. Sorry, I should cut the answer as well. So what is E negative Z square? IY square. So that means what will be this one will be E of negative of x squared. Okay, 2ixy, so minus of 2ixy And then iy times iy, I will have negative y squared. So negative y squared, positive y squared. So that means I separate among the real number and the imaginary number, I will have something like this. EY squared minus x squared, and then E negative 2i xy. Okay, so that means I will have EY squared minus x squared, and then this part, it will become cos of negative 2xy, and then minus minus, so minus of negative I sine 2xy. But because it's cos, so no matter cos positive or negative, still positive. So this one will be, but how, why the answer is different? I don't know. Let me check. Okay, so what is your real part? Real part will be this one and this one. What is the imaginary part? Will be this one and this one. So it will become EY squared minus x squared cos 2xy. Sorry. And then minus I times EY squared minus x squared sine 2xy. So that means this will be your real part. This one will be your imaginary part. So yeah, correct. This one will be your answer for real and imaginary. Again, have a look before I proceed again. And later you try the 3-2. 3-2 will be almost the same as 3-1. Okay, I proceed again. If you have no questions. Okay, number 4. Okay, W is EZ, where Z is this one. Okay, so this is the, I mean, this is a function. Okay, find the image of the in the W plane of the rectangular region. Okay, X is between 0 to 1, Y is half to 1. Okay, sketch your W and Z plane clearly. Okay, so now we'll try to sketch a Z equal to X plus IY first. Okay, what will be your Z plane? Okay, because your Z will be X is between 0 to 1. Y is half to 1, so half to 1, let's say somewhere here. So this one will be your x and y. So hence this one will be your alamat cannot. Hence this one will be your z plane. And then after the transformation of w equal to ez. Okay, w equal to ez, then you should have okay, we have to calculate first lah. Okay, w to ez, w is equal to ez. So that means is ex eiy. In other words, what you have is ex times the cos. This one you want to write or not, up to you lah. I mean here lah, this part. Okay, because what we know, this one, this is your modulus. This one, okay, this and this is your angle. 1 minute, huh? So now, because this one, okay, you were having u plus iv. Okay, u plus iv, where your u is ex cos y, and then your v is ex sin y. Okay, so when your u is between 0 to 1, okay, when your your x is between 0 to 1, so this one will be in between of your u will be in between of cos 1, cos y. Let me think. I think let me check the answer, will be easier. This is questions number 4. Oh, so many versions. Okay. Okay, so basically, okay, this is a version 1. Later I will let you see the version 2 and 3. Okay, so that means if I don't want to compare, that means now this one will be my how to say, this one will be my modulus. Okay, but my modulus will be, that means my w will be in between of E0, which is 1, and E1, which is 2 of something. Okay, so that means you will have 2 circles. Okay, and then your argument will be your y. Okay, your argument will be your y will be in between half and 1. Okay, half and 1, this is 0, this is pi over 2. Pi over 2 is shift pi divided by 2, I get 1.57, so this is 1.57, so it's between is between half and 1, so it's between 0.5 until 1, so it's something around here. So this one will be your region. This one will be your region, which represent by y equal to ez. Okay, have a look, try to understand. Okay, so we have a look for the second version. So let's say my W is EZ, and then it will be this one basically is the same. Okay, no need this one, no need. It's the same. It's the same thing. This one also the same, so it's okay. Just understand the first version will do. Okay, I proceed. Yeah. Okay, question 5. Okay. Question 5 again. I do the 5A and C, you do the D and B. Okay, so I know that my FZ is equal to cos Z. Okay, and then what is cos Z? Cos Z is cos of x plus IY. And then if you expand it, it will be cos A, cos B, minus the sine A, sine B. So this is the expansion of this one. So hence I want to compute this one. So cos of 1 plus 2i. So according to this formula, it will be cos 1, cos, okay, your y is still, your y is 2, so 2i. Let me think. Find the express for the function uv in terms of xy. uv in terms of xy. Okay, I don't want to do like this. So we go back to the formula. Formula in between the not this one, in between the cos and the cos, not this one as well. This one. Okay, or here lah. Okay, so that means what I see cos iz is cos hyperbolic z. So same thing here. Cos iy. So what is cos iy? Cos iy will be cos y. Okay, and then sin iy. Do we have anything with sin iy? Okay, sin iz, I will have I sin hyperbolic z. Sin iz, I will have sin hyperbolic I sin hyperbolic z. So that means this one I will have I sin x sin hyperbolic y. So now if you want to find the cos of 1 plus 2i, okay, because we want to get the u and v lah. That means u plus iv lah. Okay, that means this one will be my u, this one will be my v. Okay, so if you want to find the cos of 1 plus 2i, then according to the formula, it will become cos of 1, cos of 2, minus I, and then sine of 1, and sine hyperbolic of 2. So this one will be your answer. Of course, you can get it by your calculator lah, also can lah. Okay, try to have a look before I proceed again. Okay, I proceed again. Question 6. Okay, I want to show that this one simple lah. Just now we show already lah, but never mind. I will do it again. Cos z is equal to cos x plus iy. That means it will be cos a cos b plus sin a sin minus sorry minus sin a sin b. And then cos iy I can make it into cos y. Sin iy I can make it into I sin hyperbolic y. Okay, so for the same thing, sin z will be sin a sin b, sin a cos b, a direct procedure, plus cos a sin b. And again, because I've got I, so I make it, I remove the I or make the I to in front, but cos it will direct make it into cos hyperbolic. Sin will become I outside. Okay. Okay, hence I have proved the A and B. Okay, next one, this one. So if you want to find this one, the modulus square of this one, then it will become square of this one plus square of this one. So that means we'll have cos square x, cos square y, and then plus sine square x, sine hyperbolic square y. Okay, so what we do here, since I still have this one, so I try to substitute this one. So cos square x, this one will become 1 minus sine, is it? I'm not so 1 plus, okay? 1 plus. So cos is 1 plus sine. Okay, sorry. 1 plus sine hyperbolic square y. And then plus sine square x, sine hyperbolic square y. So if you time inside, you will have cos square x plus, okay. So if you times inside, you will have cos square x. And then this one both have the sine hyperbolic square y. So I take out, and then I will left cos square x plus sine square x. So it means I only will have cos square x plus sine hyperbolic square y, because cos square x plus sine square x will give you 1. Okay. Continue the same thing, you should be able to get the t. That means it will be square of this one plus square of this one. Again, make your cos into the 1 plus sine square sine hyperbolic square y, then you will get something like this. Okay, try to do. Okay, I proceed to E and F lah. Okay. Okay, so how are we going to proceed? The C, basically we start from here. I do it here. So since I know that cos Z square is equal to cos square x plus sine hyperbolic square y. So that means this one actually is equivalent to, let me see, okay. So basically you will have something like this. Okay, and then cos square x is always greater than, cos square x is always greater or equal to 0. Okay, so if you remove, then this side will be automatically will be less. So that means you will have something like this. Okay, since sine z, sine hyperbolic z, and because it's modulus, so must be something greater than 0. And then cos z is also the same, something greater than 0. So that means you will have, you can remove the square directly. Okay, so hence I done the half side. Okay, and then you try to think on the second side. Okay, and then we continue. Another side, how? Okay, I know that cos z is between -1 and 1. Okay, and the one. Okay, I use this one. Let me think a bit. Mm, okay, I use this one. Okay, I directly do this one. Okay, so I know that my cos x is always in between -1 and 1. And if I have cos square x, then it will be in between 0 and 1. Okay, so that means my cos z squared, highest will be when my cos square x is 1. So it's always less than 1 plus sine hyperbolic square y. And then another side is always greater than 0 plus sine hyperbolic square y. So this one quite clear. We get one side already. Another side is this one. This one actually is okay 1 plus sine hyperbolic square y. Again, we refer to this formula. 1 plus sine hyperbolic square y will be cos square hyperbolic y. So that means this one will become okay. Hence, we will get something in the square. That means it's always positive. So it's the same if you took out the square. Okay, then directly you can get the answer. Again, have a look. This one, I tried to use something we proved before. For the f will be the same thing. Okay, f will be the same thing by using the d. So this one I will leave it to you. F will be same as d. I mean, sorry, f will be same as e is using the d. E is using the c. Okay, try to copy down and then later you try to do on the f. Okay, so now it is 5 o'clock, so I will stop here. Next week we will do the same. Okay, we will do the same, we will do online class. Okay, and before we end the class, I have one thing I want to discuss with you. Okay, as I check, 1 minute. Hmm.